Okay, so this video is on hyperbolas. Now, if you remember from yesterday, I asked you on your ellipse notes to write the word size at the top because ellipses are all about size. Hyperbolas are all about position. Okay, so it's all dependent on which letter comes first. It has nothing at all to do with the larger number. All right, so on this example, because the x is coming first, you can see that this hyperbola opens left and right. Okay, and on this one, where the y comes first, this hyperbola opens up and down. Okay, it has nothing at all to do with the size of the numbers. All right, so this is going to be considered to have a horizontal transverse axis, and this one has a vertical transverse axis. The center, just like with circles, just like with ellipses, is going to be HK. The vertices, just like with ellipses, are going to be A units away, and the focal points are going to be C units away. And then if you'll notice here, I have this equation to help me find C. It is different. It's very similar, but it is different from the ellipse one. On the equations for hyperbolas, notice that there's subtraction in the middle, right? Which is opposite of the sign that you're seeing here in the equation for the focal points. All right, so again, that happens on ellipses too. On ellipses, if you remember, there's plus signs in the equation, but for the formula for the focal points, it's subtraction. Okay, so at the beginning, these are going to really feel like you're doing ellipses, like a lot. Let me show you what I mean. So on this first example, the center is 0, 0. Let me put that on my graph. Okay, just like ellipses, I see this 9 under the x, so I'm going to count out 3 units in the x direction, right? In the horizontal direction, I'm counting out 3. And in the y direction, because of that 16, I'm going to count out 4. 3, 4. 1, 2, 3, 4. And if this was an ellipse, this is where I would go ahead and start drawing my oval. But this is not an ellipse. This is a hyperbola. So that's where sort of the similarity ends. So what I need to do is to draw a little rectangle through those dots that I just drew. Okay, I'm hoping you can see this rectangle. Okay, and the reason you draw the rectangle is because you have to also draw in asymptotes, right? 2 dotted lines that the hyperbola gets close to but doesn't ever touch. So it goes through the center, the asymptotes, and it goes through it's literally the diagonals of that box that you just drew. So it's going to look like this. On my iPad where I'm making this video, I do not have the ability to use a straight edge, so I'm doing the best I can. On your paper, if you have anything straight to draw this with, it just makes it a lot easier. Okay, so there are the asymptotes. Okay, that's actually not that bad. I'm actually kind of impressed with myself. Okay, so because the x comes first, right, it's all about position. It has nothing at all to do with the fact that 16 is larger. It has everything to do with the fact that the x comes first. This hyperbola goes through, let me highlight for you. It's only going to go through this dot and this dot. It's going to look like this. Oh, that should not be a highlighter. Let me try that again. Here we go. It's going to go like this, and like that, and like that, and like that. There's the first hyperbola you've ever drawn. Okay, so the vertices are those 2 highlighted ordered pairs, right? It's the only spots that the hyperbola actually touches. So in this case, it's plus or minus 3, 0. Okay, the transverse axis is the distance between those 2 highlighted dots, which will be 6. And the conjugate axis is the distance between the other 2 dots. Okay, so the transverse axis and the conjugate axis are going to be the dimensions of that rectangle that you drew. Okay, it won't necessarily be larger and then smaller. okay? It depends on which letter comes first, right? It's all about position. Okay, now there's going to be focal points, all right? And they are going to be inside the curve, which means that, let me switch colors here, that somewhere over here I'm going to have a focal point, and somewhere over here I'm going to have a focal point. Let me use the formula. All right, it is c squared equals a squared plus b squared. For this example, one of those is 9 and the other one is 16. That gives me 25. The square root of that is 5. So from center, 1, 2, 3, 4. Here's one focal point. And then here is the other. Right? And I can name those. Those are both 5 units away from the center. All right, and then the asymptotes. I need the equations of them. All right, so this is how I'm going to approach this. I tend to deal with the positive slope first. So if you're noticing, this line here is the one with the positive slope. Its slope, I'm trying to figure out where I can fit this. I may need a separate sheet. Maybe not. I don't know. We're going to find out right now. That particular slope is, let's see, up 1, 2, 3, 4, and over 1, 2, 3. So 4/3. And it goes through the origin. So I know what my b value is. So the equation of that line is y equals 4/3 x. Now the other line, right, this one that I'm highlighting in purple, it has a negative slope. Right? It's the same slope as the other line, just negative. All right? So that slope is negative 4/3, and I can tell what the y-intercept is. So its equation is y equals negative 4/3 x. Okay. So for this next one, let's start with the center. Be really, really careful. If you get the center wrong, then you're going to get everything wrong. All right, and if you're looking, again, close enough, the center is at -2, 1, right? The x is coming second here, all right? So that's why the -2 is coming first in the center. Let me put that on my graph, -2, 1. Okay, from that center, I'm going to be counting left and right 3. And up and down 7. 1, 2, 3, 4, 5. Okay, so now that I've got those drawn out, I actually could probably name the transverse and the conjugate axis because I know this thing opens up and down. So since it opens up and down, I can tell that the top dot and the bottom dot are 14 units apart from each other, and that the left and right dots are 6 units away from each other. Okay, so let me draw in the rectangle so that I can then draw in the asymptotes. Okay, so again, there's my rectangle that goes through the dots that I drew. Now, on your paper, this is going to look amazing because you're going to have a straight edge. I don't have a straight edge. I'm doing the very, very best I can. Something like that. Okay, again, use a straight edge on your paper, okay? Okay, and this thing opens up and down, so the parabola is actually here. Okay, now based on the picture, I know where the vertices are, right? The vertices are at the top and the bottom. So they are at -2, 8, and they are at -2, -6. Okay, and then somewhere within those curves are the focal points. So I'm going to have to use the c squared equals a squared plus b squared formula. So let's see, 49 and 9 is 58. So c is the square root of 58, which is just a touch more than 7, but less than 8. So here and here. All right, and I should be able to name that because I know where the center is, right? And this was an adjustment up and down. So I'm going to add and subtract it from the y coordinate. Okay, now let me, I'm going to need to erase some stuff so that I have room to find the asymptotes. So just give me a really quick second. Okay, so now I'm going to come up with the equations of the asymptotes. The positive slope on this line, the only one that has a positive slope, is, let's see, 7/3. All right, and I know that because that's how far I had to count from center up and to the right, 7/3. And the only ordered pair that I know that it goes through is -2, 1. So I'm going to do point slope form. So I'm going to have y minus y is equal to m times x minus x. All right, now if you fraction bust this, that means this side will get multiplied by 3. And the 3 will disappear from the right. And then I'm going to distribute the 7 at the same time. So I'm going to fraction bust and distribute at once and get 3y minus 3 equals 7x plus 14. So then I'm going to add 3 to both sides and get 7x plus 17 and then divide everything by 3. So my first asymptote equation is 7/3 x plus 17/3. Okay, now the other one, I'm not sure why, there we go. The other one has a slope of -7/3, but the same dot, right? It's still going through here. So y minus 1 is equal to 7/3, actually -7/3 times x minus x. So I'm going to fraction bust and distribute all in one step. 3y minus 3 equals -7x minus 14. I'm going to move the -3 to the other side, which makes it -11. And then I'm going to divide everything by 3. So the last asymptote equation is -7/3 x minus 11/3. Okay, I actually highly recommend you do this problem, right, on your own, right? Pause the video, do the problem, then play the video again and see how you do. But I am going to do it for you, obviously. The center here is at 3, -2. I'm going to be counting up and down, actually, and left and right, all the same amount, because those are all 4s down there. Okay, and then here's the box. And, ooh, this is actually a really nice little square. So I know what the slopes are right now. So they're 1 and -1. So I just want to make sure I draw this really well so that when you go to find the equations of the asymptotes, they're easy to see just by looking. Okay, so because the y comes first, right? Hyperbolas are all about position. This opens up and down, which means the transverse axis is 4, and actually so is the conjugate axis. The vertices are the top and bottom points, so they are 3, 0, and 3, -4. C squared is going to equal a squared plus b squared. In this case, 4 plus 4. C squared equals 8. So C is 2 rad 2, which is just a touch more than 2. I drew them in there. Let me name those. That's -2 plus or minus 2 rad 2. And then the asymptotes, this one has a slope of 1 and the other one has a slope of -1. And you can see the y-intercepts. Like, it's just, this one comes out really, really nice. So one of them is x minus 5 and the other one is -x plus 1. All right, I've got 4 problems down at the bottom. This video is a lot longer than the others, and I apologize. All right, so let's see. Remember how yesterday when it said write the equation of the ellipse and I was immediately able to put in the skeleton? You can't do that with hyperbolas because I need to know which way this thing opens first. So let me start instead with the vertices, right? These vertices. If I have one at -3, 0, and one at +3, 0, then I know the center and I know how far to count. So the center is 0, 0, and since it opens this way, the x comes first. So I'm going to have x squared minus y squared equals 1. And I know that I counted out left and right 3, so this number has to be a 9. All right, and then since the focal point is here at 4, right, that means that c is 4. So let me write in this formula, a squared plus b squared. C squared in our example is 16. We've got a squared, so all we're missing is the b squared, which would be 7. All right, let me scoot this over. This will be sort of similar. I have vertices at negative 10, 3, and positive 10, 3. So I'm thinking of this graph here. Negative 10, 3, positive 10, 3. That means it opens left and right, and my center is at 0, 3. So let me put the x first. X squared minus y minus 3 squared equals 1. And I know to get from the center to one of those points was a counting of 10, which means this must be 100. All right, and then it looks like focal points are at negative 12. Okay, so C is negative 12, or C is 12. All right, so C squared equals A squared plus B squared. So 144 equals 100 plus B squared. That means B squared is 44. All right, 2 more to go. Write the equation of the hyperbola centered at the origin. Okay, that's cool and all, but I don't know which letter comes first, so I have to start with the vertices. 0, 1, and 0, negative. Oh, so this opens up and down. The y comes first. Y squared minus x squared equals 1. And it looks like we counted up and down 1, so this is just a 1. And then focal points are here. Okay, so C is 2. Again, it's always counted from center. So if C squared is equal to A squared plus B squared, and we know that C is 2, that means C squared is 4. I'm pretty sure here that B squared is going to be 3. All right, and the last example. All right, write the equation of the hyperbola with vertices at, okay, so let me draw again, quick picture. 1, negative 1, and 1, negative, oh, way down here, negative 9. This is 1, negative 1, and 1, negative 9. So I've got center at 1, negative 5. Is that 4 away from each? Yeah, it is. Okay. And it opens up and down. So y plus 5 squared minus x minus 1 squared equals 1. And we counted 4 up and down. So that makes this a 16. Okay, now it also says there's a conjugate axis length of 6. Okay, so the transverse axis is 8. But from center, this whole thing this way is 6, which means it's 3 on each side, which means that's a 9. All right, I hope to be back tomorrow if I'm feeling better. Feel free to remind me if you have questions or email, and the answer key is already posted.